66 million years ago, Earth belonged to the dinosaurs. Massive apex reptiles patrolled every continent, dominated the oceans, and ruled the skies. Far below them in the biological hierarchy were the early mammals. They were tiny, subterranean creatures that spent most of their time in hiding, scraping by on whatever meager calories they could find. Then, a piece of rock, roughly 12 kilometers wide, entered the picture. It was tearing through the vacuum of space at over 70,000 kilometers per hour, locked on a direct collision course with our planet. While we visualize this impact as a total apocalypse, the specific mechanics of this extinction determined which branches of life would vanish and which would eventually lead to us. To understand our own origins, we have to look at the exact, inescapable sequence of destruction that cleared the board. This satellite map shows Mexico's Yucatan Peninsula. This precise location is where the space rock slammed into the Earth's crust, carving out the Chicxulub crater, a massive scar nearly 180 kilometers wide. The kinetic energy released in that single fraction of a second equaled the simultaneous detonation of billions of nuclear bombs. At ground zero, temperatures spiked to several thousand degrees, instantly vaporizing the solid crust. The blast sent shockwaves tearing through the crust, triggering mega-earthquakes that violently shook and fractured the surrounding continents. The displaced oceans surged outward. Walls of water hundreds of meters tall raced across the globe, battering coastlines thousands of miles away. The force of the impact was so intense that it blasted millions of tons of molten rock and debris completely out of the atmosphere and into space. Minutes later, that same debris fell back down. It re-entered the atmosphere as billions of burning meteors, showering the planet and igniting global forest fires. In a matter of hours, a single rock had turned the surface of the Earth into an inescapable burning furnace. The disaster continued long after the fires burned out. A suffocating blockade of pulverized rock, dust, and ash filled the upper atmosphere, completely blacking out the sun for months. This animated diagram illustrates a basic terrestrial food web. Energy flows from the sun down to the plants, up to the herbivores, and finally to the apex carnivores. The global darkness severed that initial connection, stopping photosynthesis entirely. Without sunlight, the plants withered and died. The entire foundation of the ecosystem crumbled. The massive herbivores that relied on those plants slowly starved to death. And without the herbivores, apex predators like the Tyrannosaurus rex lost their only food source. The collapse moved straight up the chain. The Earth entered a brutal, freezing global winter that lasted for years, ultimately wiping out nearly 75% of all species on the planet. The very traits that made the dinosaurs so successful, their immense size and massive caloric needs, became the exact reasons they starved in a reset world. This reset created a biological loophole. Those tiny early mammals survived precisely because they were small. They lived safely underground and required very few calories to stay alive. They eventually emerged into a world wiped clean of giant predators, free to repopulate and evolve. Every human being alive today traces their lineage directly back to those scavenging survivors. If the asteroid's trajectory had been off by just a fraction of a degree, it would have sailed cleanly past Earth. The dinosaurs would likely have continued their reign uninterrupted, dominating the environment indefinitely. Our cities, internet, and technology, our entire civilization, exist only because of the total annihilation of the world that came before us. The cosmos remains just as chaotic today. Near-Earth asteroids pass by our planet every year, representing an active and persistent threat to our civilization. Today, international space agencies constantly track and monitor the sky for potentially hazardous objects. Space agencies are currently testing kinetic impactors and deflection technologies designed to manually alter an asteroid's path long before it reaches us. Humanity is safer today for one simple reason. We carry the terrifying knowledge of exactly what a single space rock did to this planet 66 million years ago.